Thank you all. Thank you, Dragos. So this presentation refers to harmonization of strong ground motion parameters and monitoring improvement using low-cost accelerometers in the eligible area. In fact, it's an effort of all involved partners. Yeah, the presentation outline is in these 4 steps. The question, most of these fundamental questions have been already discussed, but just repeat and go in details with respect to the harmonization. First, why REDAS in cross-border area? Then, what does harmonization mean and why do we need it in the cross-border area? What is the role of low-cost accelerometers? And finally, what does it mean at the end of the day in terms of contribution to seismic risk reduction? Please, Dragos, next. So why REDAS? That's the basic question. What are the targets? All of us know that worldwide there are several tools to estimate earthquake damage, started 20 or 30 years ago almost. However, next, please. All these have been developed within a country's or a specific territory area with homogeneous ingredients with respect to input. The question is, what if neighboring countries are hit by a shock, by an earthquake? How will it work in the cross-border area? That was the basic question. Next. Yeah. So that's why the main targets, as have been referred by Kostas and Dragos previously, main targets can be summarized in 3 points. One is the outputs of the system, and of course, the one basic point is the adaptability to other areas, because now the consortium is just 4 countries, but in the Black Sea Basin there are many more, as well as beyond it. And I will remind you here, let's remember the Vrancia 77 big earthquake, the disastrous event, not only for Bucharest and Romania, but as well as to Moldova. And you can see that the need for harmonized intensity assessment was necessary. Next, please. And in the last 3 years, in the Greece cross-border area, 3 disastrous earthquakes occurred. The recent one in Samos of magnitude 7 affected both countries, Turkey and Greece, and the need for a harmonized SAIC map was necessary. Yes, please. So, what is the targets of harmonization? Each partner was involved in this harmonization process in order to provide, first, seismic faults and sources in its territory. Second, the most appropriate ground motion prediction equations after testing and ranking. Third, geodata with respect to the VS30 maps that will contribute to the amplification of ground motion in the cross-border and eligible area. Of course, the building vulnerability models that will be discussed later, and the geotechnical issues like liquefaction, landslides, already presented by Nikos Klimis. That was the target of harmonization issues. Second, please, next. About seismic sources. The path here has already opened. You can see that the area of interest, the Black Sea area, is in fact including a quite complex seismotectonic setting. Almost all type of seismotectonic regimes are here. Shallow crustal earthquakes, intermediate depth earthquakes, subduction zones, stable cratonic mass sources, etc. So what is important next here is the adoption of the SER model, the model that was presented in the European level with some refinements, of course. Regarding the GMP selection and testing, here the ongoing work, which is still in progress, includes selection of candidate ground motion prediction equations in all 4 countries based on several criteria, test of these models with respect to the data recorded in these cross-border areas, and proposition at the end of a logic tree after the final selection to include it in the system. Next. Next, please. Yeah. So I will go fast in this transparency. This is in fact the theory of the GMP selection and testing based on the known Kullback-Leibniz divergence of a certain ground model and the data recorded in the cross-border area. Next. The basic goal, no, please, the previous one. The basic goal of this strategy, is to determine the smallest but most reliable set of ground motion prediction equations in order to capture all epistemic uncertainties of ground motion prediction in the cross-border area. Yes, please. So this testing and selection has already started. It's an ongoing work between the partners. For example, here we show you a recent earthquake in Bodrum Kos that provided data both in Turkey and in Greece, and then some models at the right part of the slide were tested against recorded ground motion. Here is spectral acceleration in several sites in Turkey and Greece. And then next, another test here, and an effort to select appropriate ground motion models in the recent earthquake of Samos 2020, testing several models of ground motion prediction and data recorded in both sites in the cross-border area. This is an ongoing effort, and in the next month or 2 months will be finalized, this deliverable. Next, please. So another issue is the geodata in the please, the previous one. The geodata in cross-border and whole the eligible area. As mentioned in the previous presentation, peak relief is very important in the VS30 estimation, the amplification. Now, what we have in hand in the cross-border area is VS30 values based in the USGS model of Wald et al. However, we are in progress of refining it by using this 5x5 digital elevation model. And certainly, if we are based on this refined one, we can improve the VS30 values, and then we can have more reliable amplifications and shake maps. Next, please. Okay, this has already been shown by Kostas, and all we know that the more instruments monitoring the area we have, the better the resolution of the shake maps and the estimation of the radar, of the radars. However, we cannot have thousands of instruments because they are costly. And in this case, we decided to develop in some pilot sites like Thessaloniki, Ceres, Xanthi, etc., around the Black Sea basin, to work with additional low-cost accelerometers. This is also a component of the harmonization. Next, please. And the same philosophy that we follow with the permanent strong motion network in these countries, in the Black Sea area, will be adopted for the low-cost instruments that will provide data to the data repository in real time, and then after the alerting is inserting in the radars, it will be included to estimate a reliable shake map, but in the level of a metropolitan area, like Thessaloniki, like Constanta, etc. Next, please. So this is in fact the low-cost accelerometer made in-house in the institute. That was the first generation, a standalone, small, low-cost sensor and digitizer. As you can see, it's 12 centimeters by 6 centimeters. And it was tested for years in a high seismicity area of Lefkas in Greece, and provided real-time, not real-time in fact, but shake maps, observed shake maps, since about 20 of them were installed in the city of Lefkas. Parallel, they were collocated in some sites with the high broadband, high resolution instruments of the Institute, and provided very good similarity, almost identical data as of the broadbands. So they are tested. The second generation, which is high resolution of 19 bits now, plus continuous data streaming to the center, to the data center, they will provide all what we need in the real-time estimation with a low cost, especially focused on the pilot sites of metropolitan areas in the Black Sea. And this low cost, next please, and this low cost have been deployed, will be deployed, this is the plan in the REDACT project, will be deployed in 32 schools, at least in Thessaloniki, plus another, next, 5 schools in Ceres. These are the 2 first pilot sites that will, where we will implement this application, and after we have some results and the reliability and quality control tests, this can be also applied to the rest of the pilot sites in the Black Sea basin. Next, please. This was shown by Dragos, that was decided to be the area of interest with a buffer zone of 300 kilometers around the borders of all countries in the Black Sea Basin. And the alert system was discussed and the triggering area. Yes, please. So in study, next, please. So in summary, just to repeat once more, we will have 6 servers, 6 fully operational systems, participants, and they will serve exactly the same data, ground motion data, geo data, except the building inventories. As we mentioned, this is due to the restrictions imposed by each country. This is an open issue, we will see. And so the harmonized data will enter these 6 operational systems and will provide identical results. So in case of failure of one of these, the other will provide the results. This is a kind of redundancy within the project. Next, please. So, concluding, although harmonization was the issue of the main topic of this presentation, we can say that harmonization will help to this multinational Black Sea Basin effort and will contribute to mitigate the consequences, the bad consequences of future events. How? By guiding positive emergency plans, by reinforcing preparedness and response capacity of civil protection citizens a priori, after training activities, and supporting decisions that will be made before the event, say the preventive measures, and during, of course, the recovery phase a few hours after. Ensure resilience for the society, rural areas, as well as in metropolitan areas. Definitely a question that may be discussed at the end of the round table. What about the sustainability of this system? We believe that all countries that are involved in this effort, and because they are exposed to high seismicity and risk, will be interested to continuously operate the system that will be built in this project. Already, most of these countries involved in the REDACT operate seismic networks and have long experience in seismic risk assessment, and these are their mission. And definitely, there is an ongoing European initiative towards European SAKE-MAP, and collaborating with this in the near future, we can also add to the sustainability of the system. Thank you, and sorry for all these disruptions and connectivity problems. Thank you.